Hello everyone, welcome to Abhi online classes. Today I am going to discuss some questions in limits and continuity which were asked in competitive exams. Let us see, the first question is, if f of x is equal to 3x plus mod x by 7x minus 5 mod x, where x is not equal to 0, then limit x tends to 0 plus f of x, right-handed limit, and limit x tends to 0 minus f of x, this is a left-handed limit, or respectively, first option is 2 minus 2, second 2 1 by 2, third option 2 1 by 6, fourth option 2 comma minus 1 by 2. Let us see the answer is, first we find out right-handed limit. Limit x tends to 0 plus f of x. Right-handed limit. Limit x tends to 0 plus f of x. Limit x tends to 0 plus, here it is given f of x is 3x plus mod x by 7x minus 5 mod x. So first we see the definition of mod x. Mod x is equal to plus x, mod x equal to minus x, and mod x is equal to 0. Mod x is equal to plus x if x is positive. Mod x is equal to minus x if x is a negative. Mod x is equal to 0 if x equal to 0. This is the definition of mod x. X is greater than 0 means it is in the positive neighborhood of 0. X is tending to 0 plus. X is less than 0 means it is in the negative neighborhood, that is x tends to 0 minus, we should take mod x as minus x. If it is in the positive neighborhood, if x tends to 0 plus, we should take mod x as plus x. Since here x tends to 0 plus, limit x tends to 0 plus 3x plus, x tends to 0 plus means mod x is equal to plus x, so we write it as plus x by 7x minus 5x. Now this is equal to limit x tends to 0 plus 4x by 2x, cancel x, and this is also 2 times. Limit of constant is constant, so we got right-handed limit 2. Now we see left-handed limit. Limit x tends to 0 minus f of x. Limit x tends to 0 minus, same, f of x is 3x plus mod x by 7x minus 5 mod x. Now this is also equal to limit x tends to 0 minus 3x. If x is in the negative neighborhood of 0, we write mod x as minus x. So we should write this mod x as minus x by 7x minus 5 into mod x is minus x. Because x is in the negative neighborhood, x tends to 0 minus, we should write mod x as minus x. Limit x tends to 0 minus 3x plus into minus minus x by 7x plus 5x. Now this is equal to limit x tends to 0 minus 2x by 12x, cancel x, and we also cancel 2. Limit of constant is constant, so we got a left-handed limit 1 by 6, right-hand limit is 2. Therefore answer is 3. The option 3 is the correct answer. So right-handed limit is 2, left-handed limit is 1 by 6. So therefore for this question answer is the third option. Now we'll see second question. Examine the function defined below for continuity at x is equal to a. F of x is equal to 1 by x minus a cosecant of 1 by x minus a when x is not equal to a. F of x equal to 0 when x is equal to a. First we'll see right-handed limit. Limit x tends to a plus f of x. Limit extends to a plus. For a plus as well as for a minus, for both we should take this f of x. F of x is 1 by x minus a cosecant of 1 by x minus a. When x is tending to a, we write x as a plus h as h tends to 0. Limit h tends to 0, 1 by a plus h minus a. We are writing a plus h in place of x. We replace x by a plus h. Cosecant of 1 by a plus h minus a. Cancel a. Limit h tends to 0, 1 by h, cosecant of 1 by h. Limit h tends to 0, 1 by h. Cosecant of 1 by h, we write it as 1 by sine of 1 by h. Now, as h tends to 0, h into sine 1 by h also tends to 0, because as h tends to 0, 0 into finite quantity, sine is a finite quantity. So 0 into something gives 0. Therefore, 1 by 0, that is equal to plus infinity. Now, left-handed limit. Limit extends to a minus f of x. Limit extends to a minus, here f of x is 1 by x minus a, cosecant of 1 by x minus a. We replace x as a minus h as h tends to 0. Because here x is tending to a minus, we are replacing x by a minus h. Limit also changes. Limit h tends to 0, 1 by a minus h minus a, cosecant of 1 by a minus h minus a. Previously we have seen in place of x we are writing a plus h. Now we are writing in place of x a minus h. Cancel a. Limit h tends to 0, minus 1 by h, cosecant of minus 1 by h. Limit h tends to 0, minus 1 by h into sine of minus 1 by h. We are writing cosecant theta as 1 by sine theta. As we all know, sine of minus theta is equal to minus sine theta, because this is an odd function. So sine of minus 1 by h, we write it as minus sine 1 by h. So minus into minus plus. Limit h tends to 0, 1 by h into sine of 1 by h. Same. As h tends to 0, h into sine of 1 by h also tends to 0. 0 into finite quantity is again 0. 1 by 0 also, it gives plus infinity. Previously we have seen limit h tends to 0, 1 by h into sine of 1 by h. h into sine of 1 by h tends to 0 as h tends to 0. Now 1 by 0 gives plus infinity. We have seen right-handed limit extends to a plus f of x is equal to plus infinity. Limit extends to a minus f of x, left-handed limit also is giving plus infinity. Both are equal. And the third one is, now we put x, in place of x we write a. So this is x is equal to a, we put here. F of a is equal to 0. This is the third one. We'll see one more problem. F of x is equal to 1 minus cos 2x by x square when x is not equal to 0. And f of x is equal to k when x equal to 0. Is continuous at x is equal to 0. Now we have to find out the value of k. Given f of x is equal to 1 minus cos 2x by x square when x is not equal to 0. When x is equal to 0, f of x is equal to k. F of x is equal to k when x is equal to 0. In the problem itself it is given the function is continuous. It is given the function is continuous. Since f is continuous at x is equal to 0, therefore limit x tends to 0 f of x equal to f of 0. Since f is continuous at 0, by definition limit x tends to 0 f of x is equal to f of 0. Limit x tends to 0, f of x here is 1 minus cos 2x by x square, and f of 0 it is given k. Limit x tends to 0, 1 minus cos 2x in trigonometry we know this is equal to 2 sin square x by x square. We bring a 2 outside of the limit. Limit x tends to 0. We write a sin square x by x square as sin x by x whole square. And we know limit x tends to 0 sin x by x value is 1. Therefore k value is equal to 2. Therefore k answer is 2. Once again I repeat, given f of x is equal to 1 minus cos 2x by x square when x is not equal to 0. When x equal to 0, f of x is equal to k. In the problem it is given f is continuous at x equal to 0. Therefore by definition limit x tends to 0 f of x is equal to f of 0. In this problem f of 0 is equal to k. And f of x is 1 minus cos 2x by x square. We know 1 minus cos 2x is equal to 2 sin square x by x square is equal to k. Limit x tends to 0. Now we bring a constant outside the limit. So 2 into limit x tends to 0 sin square x by x square, we write this as limit x tends to 0 sin x by x whole square, and now this limit is equal to 1. So 2 into 1 square 2, therefore k value is 2. Now we see fourth problem. If f of x is equal to x into sine of 1 by x when x is not equal to 0, and when x is equal to 0 f of x is equal to 1, then we have to find out f is continuous or discontinuous at x equal to 0. We have to find out. Now first we see right-handed limit. Limit x tends to a plus f of x. Limit x tends to, here a is 0, 0 plus f of x is x into sine of 1 by x. Already we have discussed, when x is tending to 0 plus, we replace x by 0 plus h as h tends to 0. Limit h tends to 0, 0 plus h. We are writing in place of x 0 plus h, sine of 1 by 0 plus h. Limit h tends to 0, h sine of 1 by h. As h tends to 0, 0 into finite quantity. Sine is a finite quantity because sine 1 by h is bounded and it is lying in between plus 1 and minus 1. It is bounded. It is a finite quantity. So 0 into finite quantity gives 0. Therefore right-handed limit is 0. Now we see left-handed limit. Limit x tends to a minus f of x. Limit extends to, here a is 0, 0 minus f of x. F of x in this problem, x into sine of 1 by x. Limit x tends to 0 minus x into sine of 1 by x. As x tends to 0 minus, we replace x by 0 minus h as h tends to 0. Previously we have replaced x by 0 plus h. Now x is replacing by 0 minus h. Limit h tends to 0, 0 minus h sine of 1 by 0 minus h. Limit h tends to 0, minus h sine of minus 1 by h. As we all know, sine of minus theta gives minus sine theta because it is an odd function. Limit h tends to 0, minus h into minus sine of 1 by h. Sine of minus 1 by h is equal to minus sine 1 by h. Minus into minus plus. Therefore, limit h tends to 0, h into sine of 1 by h. In the same manner, sine is a finite quantity and it is lying in between minus 1 and plus 1. It is a finite quantity. So 0 into finite quantity gives 0. Therefore, left-handed limit is also equal to 0. We have seen right-handed limit 0, left-handed limit 0, and in the question at x equal to 0, f of x is equal to 1. Therefore, right-handed limit is equal to left-handed limit, but both are not equal to f of a. Here a is 0. Right-handed limit gives 0, left-handed limit is also 0, and f of 0 is 1. But these two are 0, but this is equal to 1. Both are not equal to f of 0. Therefore, f is discontinuous. The given function, this function is a discontinuous at x is equal to 0. Discontinuous are so many types. This type is removable discontinuity. F has removable discontinuity. At x is equal to 0. Right-handed limit, when right-handed limit is equal to left-handed limit, but this both not equal to f of a, then we say this is having a removable discontinuity at x is equal to 0. So it has removable discontinuity at x is equal to 0. These are the very important problems for B.sc students. In the next class we will see some more problems in the limits and continuity. Hope you understood this class. Thank you.